What is a data structure and why is it important? A data structure is a way of organizing and storing data so that it can be accessed and modified efficiently. Imagine you are organizing your books on a shelf. If the books are arranged properly, finding a specific one becomes easy. Data structures do the same thing but for information in a computer. Data structures are important because they make handling data easier. For example, searching for a contact in your phone would take much longer if the names were not organized. They also help algorithms run faster. For instance, some structures allow you to insert or search data more efficiently than others. Example for real life. Think of an array like a box of chocolates arranged in a line. Each chocolate is in a specific position, which makes it easy to pick the one you want. A linked list, on the other hand, is like a train. Each carriage is linked to the next, and you can add or remove carriages without rearranging the entire train. Types of data structures: linear and non-linear. Data structures can be broadly divided into two types: linear and non-linear. Linear data structures organize data in a straight sequence. Examples include arrays, linked lists, stacks, and queues. A real-life example of an array is a grocery list written on paper. Each item has a specific position. A queue is like a line of people waiting at a ticket counter. The first person in line is served first, and the last person has to wait until their turn comes. Non-linear data structures organize data in a more complex way, such as in a hierarchy or a network. Examples include trees and graphs. A real-life example of a tree is a family tree. Each person is connected to their parents and children. A graph is like a city map where locations are connected by roads. Algorithm complexity is a way to measure how fast or efficient an algorithm is. It is like asking, how long will it take to complete a task? There are three types of algorithm complexity. Big O notation is used to describe the worst case scenario. For example, if you are searching for your keys in a set of drawers. Big O is like checking every drawer until the last one. Big Omega notation describes the best case scenario. Using the same example, Big Omega is like finding the keys in the very first drawer you check. Big Theta notation describes the average case scenario. This means finding the keys somewhere in the middle of the drawers. By understanding these notations, we can predict how efficient an algorithm will be in different situations and choose the best one accordingly. Recursion and its role in data structures is when a function calls itself to solve smaller versions of a problem. It keeps doing this until it reaches a point where the problem can be solved easily, called the base case. Recursion is widely used in data structures for tasks like tree traversal or solving problems by breaking them into smaller parts. A real-life example of recursion is opening nested dolls. When you open the largest doll, you find a smaller one inside. You keep repeating the process until you reach the smallest doll. Another example is traversing a tree. Imagine you are checking each branch of a tree one by one. You start at the root, then go to each branch, and repeat the process until all branches are visited. First, data structures are tools to organize data efficiently, just like shelves, drawers, or filing systems in real life. Second, linear structures arrange data in a straight line, while non-linear ones organize data in a more complex, interconnected way. Third, algorithm complexity helps us understand how much effort is needed to solve a problem, guiding us to choose better approaches. Finally, recursion helps solve problems by breaking them into smaller parts, much like peeling an onion layer by layer or opening nested dolls. Data structures are essential for organizing, managing, and processing data efficiently in computer science and real world applications. Let me know if you need more details or examples.
Thank you for exploring with me. I'm always here to help with more topics. Stay curious, keep growing, and feel free to reach out anytime. David, don't forget to follow and subscribe for more updates. Let's stay connected and create amazing things together.